In this project, we are going to predict whether a customer will churn or not using a credit card service. To do that, we used a publicly available dataset from Kaggle. We applied 4 distinct supervised learning algorithms to the dataset to find the best performing algorithm to do the prediction. The algorithms we applied were logistic regression, support vector classifier, decision tree classifier, and the random forest classifier. This is an overview of our dataset. There are 21 columns, and the label we are going to do the prediction is this attrition flag column. Before training the model, we had to clean and preprocess our dataset. As you can see, the education level and the matter status columns are having null values. And that is shown more graphically using this graph from this yellow areas. First of all, we drop this client number column, which is an ID given to each customer to identify them separately. And after that, to remove the null values in the matter status column, we remove all the rows from the column. And in the education level, we replace all the null values from its mod values. And in the income category, there was a category as ABC. We replaced that ABC with NAN and then replaced again with the mod value. After all the data cleaning, there were some columns still with string values. We did preprocessing to these columns. We applied binary encoding to attrition flag and gender columns. This is the function to apply binary encoding. In education level, we combine these postgraduate and doctorate categories to a new category known as other. This is the function we used. And then we applied one-hot encoding. In matter status column as well, we applied one-hot encoding. In the income category column, we applied ordinal encoding using this function. The card category as well, we applied one-hot encoding. This is the dataset after doing all the necessary cleaning and the preprocessing. That is all about the preprocessing part.
Let's take a closer look at how we separated the independent and dependent variables. We started by loading the credit card user churn data, which include various features such as credit limit, gender, education, and so on. Our goal was to predict whether user would churn or not, which is dependent variable. To separate dependent and independent variable, we drop the dependent variable from our data and store in X. It is an independent variable. We then store our dependent variable in Y. Now that we have our dependent and independent variables separated, we need to scale our independent variable to ensure that all of our features are on the same scale. This is important because some algorithms are sensitive to the scale of features. To scale our data, we use standard scaler, which scales the data to have mean of 0 and standard deviation of 1. We then store the scaled data back in X. Now that our data is scaled and our dependent and independent variables are separated, we can move on to training and testing our model. To train our model, we first split our dataset into training and testing set using the train test split function. We choose to use 80% of our data for training and 20% for testing. We then define the models that we want to use for training which include logistic regression, support vector machine, decision tree, and random forest. These are all common algorithms that are used in machine learning. We looped through each model and fit it to our training data. This means that we train our model on the training data so that it could learn from it. To evaluate the performance of our models, we print out their accuracy scores on our testing data. This gives us an idea of how well our models are performing on new unseen data. Finally, we use our trained models to make prediction on our testing data and print out the predicted values.
Moving on, let's now take a look at how to perform hyperparameter tuning for the algorithm we previously used. First, we look at the logistic regression algorithm. As we discussed earlier, our initial model gave an accuracy rate of 89.49%. To do this hyperparameter tuning, we use technique called mixed CV. In this scenario, we use these hyperparameters for the hyperparameter tuning, the regularization string and the regularization type of regularization. We can see the best hyperparameter values after doing hyperparameter tuning like this. And we can see the accuracy rate after doing hyperparameter tuning, 89%. This accuracy rate remaining the same as the previous initial performance. This report also provides precision, recall, and F1 scores in each class. And this showed the confusion metric as a plotted as a heat map. In the support vector machine algorithm, we use the regularization parameter, kernel type, and gamma parameter as a hyperparameters for this algorithm. Initially, the model with a hyperparameter tuning, we gave an accuracy rate of 92.21%. After doing hyperparameter tuning, we achieved accuracy rate of 93%. And this shows the confusion matrix of the SVC model after doing hyperparameter tuning. In the decision tree algorithm, we use max depth, minimal sample split, and minimal sample leaf as the hyperparameters. Previously, this algorithm got accuracy rate of 93.28%. After doing hyperparameter tuning, we can gain a 94% accuracy rate. These are the best hyperparameter values that can be gained using this algorithm. This is the confusion matrix for this decision tree algorithm. In the random forest algorithm, we use an estimator, max depth, minimal sample space, and minimal sample leaf as the hyperparameters. Previously, we got 95.57% as the accuracy rate. After doing hyperparameter tuning, we can gain a 96% accuracy rate. These are the best hyperparameter values that can be gained using this algorithm. This is the confusion matrix that represent in the risk according to the random forest algorithm. That's all about the hyperparameter tuning part.
In this credit card user churn prediction problem, we use for supervised learning algorithm like logistic regression, support vector machine, decision tree, and random forest to train the model. First, we are compare this algorithm with accuracy score. The random forest has 0.96, decision tree has 0.94, support vector machine has 0.93, and the logistic regression having 0.87. However, accuracy alone is not always best metric to evaluate the model performance, especially when dealing with the imbalanced data set, which is often the case in real-world problems such as churn prediction. Therefore, the models are further evaluated based on three performance metrics such as precision, recall, and F1 score. Let's see what's the precision. The precision is to give the fraction of correct positive prediction out of all positive prediction. That means true positive divided by the true positive plus false positive. Then move to the recal, it gives the fraction of correct positive prediction out of all actual positive instance. That means true positive divided by true positive plus false negative. The F1 score is the combination of both precision and recal. It is used to an imbalanced data set. According to the result, random forest model is outperform the other models in all four performance metric criteria. It has accuracy score of 0.96. As a precision score 0.96. Recal also same. The F1 score also same. This shows the random forest model predicted 96% of the instance in the dataset accurately with good precision recal and F1 score. Overall comparison, the results show the random forest model is most suitable model for predicting credit card churn or not. However, it is important to understand number of model can be not 100% accurate, but having accurate score of 0.96 is closer than 1. You can see accuracy score, all the metrics check is also closer to 1. Using this algorithm, we have some limitation as well. So those are to increase the accuracy, more training data are needed. And also hyperparameter tuning with many parameters require high computer power. And also we can use this training model to future analysis. We can use the advanced machine learning models such as assemble method or deep learning, and also we can use transfer learning the model to be used by banks. That's all about the comparison and evaluation part of O algorithm. Thank you.